Welcome back to the show. We got my friend Dario Valenza on. He's with Carbonix. He's going to help us and look, with over a decade of working on America's Cup boats, his precise understanding of engineering and material sciences, the technology, and what's important to driving each and every ounce of performance out of vehicles that race in these amazing races. He knows how to do that in today's business world. I'm so excited to have him on the show. Uh, Dario, welcome to the show today.
Great to be here. Thank you.
We start to look at the World's Cup, and just imagine you're sitting out there. You're 5 hours from a race. You're getting ready to go out. And you find out you've got this fracture in the boat. You got a fracture somewhere. Now you've got 5 hours to fix it, test it, and get ready for what might be. Some of these races have some real big impact if you don't win them. Talk to me about what are you doing when you're on the line of fire there? How are you handling this logic?
Absolutely right. You have to be prepared to end up in that situation because the boats are marginal at best. They're designed to be as light as possible to just get over the finish line and then effectively be rebuilt every time. We've had instances where something has broken at the top of the mast, for example, and there's a whole logistics chain that has to come in to pull the mast out, actually quantify the damage, locate it, come up with a plan to fix it. And in the case of carbon fiber, it'll be laminating, which means cutting carbon cloth, putting resin on it. All these different trades and logistics and bits and pieces have to come together. And the pressure is there because the race starts at 10 o'clock the next day. And you might get to 3 in the morning and still be dealing with this issue, knowing that you then have to put it all back together, get it tensioned up and tested. So the logistics in that and just being able to focus on the thing you need to do to get back on the water is really key.
I think that's something that really is applicable to today's business world, right? A lot of us get into these rabbit holes of things in business and sometimes forget we need to get back on the water, right? It's a breakdown. We got an issue to deal with. A lot of times people are looking for the 20-year fix, and I'm like, nope. Look, let's just get back on the water, and then from there we'll do some other ideas. And we're not in the middle of a gunfight. Then we could do it. And I think that applies to our day-to-day operations on a project or a program or something that we're building. For us in the construction world, it happens every single day. Like we get a breakdown, someone doesn't show up. You can make a whole thing out of it, but the goal is let's get back in, let's keep it moving.
I think it drives clarity. It's being clear on the mission. So what do we need to do? In our case with Carbonix, it's capture aerial data for the customer. So fly over their assets, take photographs, scan. We need a working machine to do that. We need the logistics. We need the regulatory approvals, and we only need the things that we need to make that mission happen. So the features on the aircraft, the preparation, the testing, and you do have issues in testing. You come up with bugs. You have to figure out, okay, what do I need to do to squish this bug, to fix it, to document it, to get it ready, to have a product that I can use tomorrow. And so that focus at the design stage, at the implementation stage, really means that you don't go and do something that you don't need to get to that point.
I mean, how many times in business have you seen someone go down a rabbit hole that's just in that where you're at in that moment? Look, it may be valuable somewhere later on, but when you're sitting there getting ready for race day or the problem, or you're in the middle of a project that's, if we don't solve it now, the domino effect of that is we're out of the game, right? For you in the boating world, you're out of the race, right?
That's exactly right. And in business, you only have so many lives because funding, reputation, competition, etc. The parallel there in racing is obviously it's more structured and artificial, where you've got to get to the finish line before the other guy, but the outcome's the same. And particularly when you're creating a market, when you're doing something for the first time, where there's a complex piece of technology that has to do a task that hasn't been done before for a customer that may not fully understand it because it's a new way of doing things, stringing all those things together is absolutely key. And when you do your initial design and you sit down and technicians and engineers, which I am, try to tend to do this a lot. It's how do you make it beautiful and perfect and put all the bells and whistles on it and get it to do all the things that you want it to do in the next 10 years. And then you have to par that down to say, okay, let's put that in time and space. Let's spread it out. Let's, MVP is sort of the cliche term, but it's really the minimum viable product. What do I need to do to make it viable, to be able to get the customer traction, show the product market fit, and then move on from there.
Let's dive into that just a little bit more. Talk a little bit more about that minimum viable product.
So in the case of drones, for example, the problem we're trying to solve is effectively getting a camera or a scanner over an asset for long enough to make a difference, to have I guess, a long enough range for your cost per unit kilometer to come down. And so range is important. Stability of flight is important. Weather resistance is important. On the other hand, something like the user interface, it has to be good enough. It has to get you to the point where you're protecting against errors from the pilot, but it doesn't have to be so polished that you can hand it over to someone with no training and they can go and operate it. That'll come later. So as an example, we look at the robustness of all our electronics and avionics, all our connectors, making sure we have robustness and redundancy where it's needed in anything that's flight critical. And then, define things where, okay, if they fail, it might mean a modification to a mission, or it might mean to come home and change something and then send it out again. So putting those in order of priority, and then deciding, how do you test it? How do you get to the point where you're happy to put this out there over a valuable asset with a customer? Do you just fly it once and that ticks the box? Do you have to do 1,000 hours? Is there a compromise where you can do 100 hours, but you can do them at a high stress level in a difficult environment? Really mapping out that envelope and saying, what corners of that envelope do I have to hit to make myself comfortable that this thing is reliable? So planning
And
all of that is really the challenge.
I think that applies to all entrepreneurs, right? So to look at, all right, look, if I'm going to go start a business, I work with people all the time, and they say, look, I'm just, they're wait too long. They're trying to get too perfect before they go to market, right? I've got to get this perfect before I'm like, no, you don't. Just start, right? I was working with a guy the other day who wanted to start a podcast, and he's like, well, I got to do this, and no, let's go to my studio right now and let's start talking. And I'm like, you got to realize that sometimes that minimum viable product means just starting, right? And the rest of it to get to a place that's good enough to get the vision out there. And truth is, your decision logic will change midstream, right? Just getting it to market starts a whole nother group of openings for learning, right? The things you think you needed that you're waiting for perfection on turn out you're like, yeah, I spent too many hours looking at 90 different cameras. Like, nope, let's just get calling, and the Apple phone I have works just fine for a camera, and let's just get started, right? And so that 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 analysis paralysis can really stop the forward movement of an idea, and I think it happens all the time.
I think it has to be conscious. So you have to be deliberate about it. For example, if you're putting out some kind of consumer software, for example, that if it crashes, you get an error message, you restart it, you keep going, and then the developer gets a bug notification and they fix it. Yes, there's a reputational risk, but that's startups. People get over it pretty quickly when the product gets better. In the case of a flying machine, there's a floor there that you can't go below. Like, the thing has to stay in the air, and so the critical components there need to be identified. You need to say, well, what can't fail, or what can't fail within the first 10 hours, 20 hours, 50 hours, whatever your goal is, and really focus on that and identify, how do I test it, and how do I test it in a way where there might be mitigations. You might have to say, we'll have to replace that part more often until we get more confidence, or we'll have to have an error that pops up on the pilot screen to say, oh, this thing looks like it's about to have an issue. It doesn't mean you have to fix it in a way that's permanent and definite. It just means you have to put yourself in a place where you've got confidence that it's not going to let you down. And then, as you say, you iterate. And in our case, the journey has been sort of twofold, right? One is the readiness of the customer, and that comes down to expectations, regulations, how they adopt the service, and there's a whole conversation we can have around that. And then the other one is the maturity of the ecosystem and the supply chain. So when we started out, we're 8 years in at the moment with the drones. The company's a bit older, but we did a lot of fundamental R&D before we went to market. There are things that we couldn't buy at the time. If you wanted a servo, for example, that ran on CAN rather than RS-232, or you couldn't get that to a level of quality and reliability that you needed on that aircraft. So we had to reinvent the wheel. We had to make boards that mediated between the two comms protocols. Stuff that you don't want to do. You don't want to reinvent the wheel. You don't want to be in the business of building the peripherals that should be part of your supply chain. But you have to make the call where you have to. And then over time, as that stuff matures, and for example, what used to be a hobby supplier suddenly gets ISO certification and starts going into the professional sort of enterprise market, then you reevaluate and you say, fine, we'll buy that thing and put it in, because our value add is not building a servo or a communications board. Our value add is the airframe, the carbon fiber, the integration. So knowing that and being flexible about, okay, I couldn't buy that yesterday, I can buy it today. Let's change how we approach it.
Look, that's interesting, right? That piece right there is very interesting. Tell me a little bit more about that. How hard is that integration? How hard is that? Now you're kind of using what you got, not what you want. You're kind of, having to kind of modify to make it work. But there's a payoff on it. You're getting a market faster. You're serving the customer quicker. It may, later on, it may be something you're going to change out, but you're getting to market with the customer.
Absolutely. You're getting the thing out there, and you're also gaining an in-depth knowledge, which then means that when you're evaluating a supplier that's now going to sell you something that you used to make yourself, you can evaluate it from a position of, okay, when we did it, these were the pitfalls. Has this supplier addressed those pitfalls, or are they making the same mistakes we made? And still, when you get the components, you want to validate it, you want to put it through tests. You don't just rely on the supplier spec sheet. But as that ecosystem evolves, you sort of gain more confidence and you have more options. And it just means that your cost base drops a little bit. You have a bit more flexibility, and you can integrate a bit better. But again, you don't change something for the sake of it. So a good example for us is the comms for the drones. So the basic comms is a radio. Radio requires line of sight. It's good for 50 to 100 kilometers depending on conditions. When you want to go beyond that, which we do because we have the range to do it, then you want alternatives. So we've gone for satellite and cellular. And with cellular, we developed our own module to do the handover between the radio and the cellular comms, so 4G LTE.
Nice. And
And
any problems with as you set that up with cell towers? And did you find anything special was different for? I mean, at the height you're flying, was there issues with that? Going from
all
ground
sorts.
with yeah, yeah,
So first of all, yeah, the cell network's designed to point down, not up. So we have
yeah.
to have special ways to sort of make that work. But the main thing is sort of the lesson drawn is we set up this board that does what we need it to do. And it does it so well that now that there's stuff on the market that sort of does the same thing, we've not swapped it out because it works. So why bother? As that stuff gets eventually that'll surpass what we have, and then we'll revisit it. But there are instances where you've kind of been forced to reinvent the wheel. You've come up with something that works, leave it and move on.
Yeah. Yeah. Here, that might be the key right there. Leave it, move on. We can always come back and do it. If it's a persisting major issue, we can always come back. But it's good enough for where we are. And sometimes that feels like you're half-assing it. And you're not, right? Part of a business is kind of identifying how to weigh these things, right? How
Mm.
to weigh the kind of how, I guess, how important is it for like for you guys for drones? How important is it to make the whole flight, make the whole project in one flight, right? Is it
Mm.
if I did it in 2 or 3 flights, but it's a lot less weight and a lot, I can do it a lot quicker, or you know, all that comes with some weighing of decision logic. I guess what's the best way to kind of explain that to the audience, right? And how do we help that young entrepreneur? Because my judgment is that young entrepreneurs don't know how much weight to throw on everything. Everything's so dramatic. Everything's so important. If I don't get it done now, though, the whole thing's going to fall apart. By the way, I've been there, right? And trying to figure out how to weigh that takes a little skill, maybe even a little practice
Mm.
over the years.
It takes us back to what we started with, the triaging when you're 2 hours before a race and you're trying to fix something. It's consciously identifying the real constraints. So, good example for us, um, we designed an aircraft that can fly for 8 hours. And the thinking of that was 8 hours gives you 800 kilometers. That's as long as you'd probably want to fly in a mission. It's more than a helicopter. It's more than a sort of small manned aircraft, and obviously carrying the weight that we need to carry. And then you go, okay, to push for that 8 hours, you get to 5, you get to 6, you keep going, you keep filling the fuel tank and doing those hours. Or you look at the other constraints and you go, hang on, if fine to have an 8-hour flight time, but the missions that we're doing at the moment, because of the constraints of daylight, of pilot fatigue, of regulations, of the specific missions that we're doing, most of the missions we're doing might be 6 hours. So let's park that 8 hours testing and concentrate on the 6 hours, and that suddenly gives us a little bit of leeway to have something that might be slightly heavier or might be a little bit more drag, which again, as a aerodynamicist, I hate that. I look at the aircraft and I go, that should be in the aircraft and streamlined. But the reality is that you've got an aerial hanging out. That might take 20 minutes of flight time away, but if you don't need those 20 minutes, then leave the aerial hanging out. We can do that optimization later and put it inside and streamline it. So consciously looking at the real constraints, like what, even though I can push performance in this direction and get this ideal thing that I want, what in the real world is stopping me from actually using it?
Yeah. So let's go back. First of all, you have drones that can fly for 8 hours.
Yes, carrying 5 kilos.
What kind of missions are those going on?
Mainly it's infrastructure scanning, and so critical infrastructure. So you look at power lines, pipelines, open cut mines, anything where you have a linear asset that's in the middle of nowhere, might be over forest, might be over desert, and not necessarily accessible. We fly low and slow for a long time to cover that whole thing in one flight, which means you don't have to send ground crews out halfway through to recover the drone and then launch it again. And so we are delivering better data more safely at about 2% of the fuel burn compared to a helicopter or a manned aircraft to do those scans. And we're doing it with a high resolution survey grade gear. So whether it's a photograph or a LiDAR scan, very precise geolocation, and we can do it in weather day in and day out. So we're very resistant to wind and heat and rain to an extent, but rain then affects the data, so it's not as critical. And that's really the value proposition, is saying get that critical ground truth, that real-time information on the condition of your assets quickly, cheaply, and safely.
Are you able to do full topographic detailed looks at property?
Yes, in the sense that when we carry a LiDAR scanner, it's called a Regal Vux 120. It's a precision optics. Again, the reason it weighs 5 kilos is it's got heat sinks and powerful lasers and all that. It basically generates a point cloud and it has multiple returns. So if you're flying, for example, over a power line that might have vegetation flanking it on both sides, and the issue is vegetation getting too close to the lines that could start a fire, we can fly over, and the returns from the laser will not just give you the top layer of the canvas of the canopy. It will also give you the layers underneath, because the laser will kind of bounce around and come back, and it's called multiple returns. So we generate a centimeter accurate 3D model of the power line, the easement around it, the vegetation next to it, for a swath of about 150 meters width. And again, we can do that for a long time.
I did a podcast maybe a year or two back, a year and a half back, with some guys that were from the Israeli army that were looking to be able to take these drones and be able to scan a property, both, do a topographic analysis, but also do X-ray through the property, right? Be able to look at, do sound, X-ray. Have you seen anything at that nature yet, where you could see into the ground at any great distance?
I think this takes us back to that triage and priorities, right? But we set out with a platform that's fairly payload agnostic. So what we carry, as long as it physically fits in the aircraft, we don't care. It does the same thing. And so there are many applications for that. You can do NDVI, which is agriculture, sort of multispectral. You can do what we talked about, scanning power lines. You can do photogrammetry, where you're taking orthomosaic photographs of terrain. And you can do what they call ISR, which is intelligence, surveillance, reconnaissance, which is a gimbal camera that gives you a live feed. We can do all of those things, and we can integrate, gas sniffers, you name it.
Wow. Wow.
for pipeline leaks, for example,
Yeah,
you,
no,
you
it's
fly
that's
over.
it's amazing how
Um,
I mean, think about the safety for that, right? I mean, now you're able to have a drone go do it rather than a human go do it, and
Absolutely.
or a helicopter go do it. Just it's a way safer environment.
Mm. But with each one of those, it's a different market. There are different considerations. There are different nuances in how you fly the mission, where you position yourself relative to the light, for example. And so we made a very conscious decision early on to look at, um, call it low hanging fruit, which is large assets, middle of nowhere, with big customers that have many of them.
Nice.
So you look at a mine, for example, you have a BHP here in Australia. You're in with one, you're in with 20 different mines. One customer, lots of needs. The mines are big. They need area, they need frequency. So it makes sense to focus on a few customers like that rather than hundreds of customers that are scattered over, ones and twos that are doing all these different things. And again, from a technologist point of view, that's really cool because every time we integrate a new payload, we're learning, it's different, there's stuff that you need to do. But from a business point of view, you really have to say the investment that I have to put into integrating a payload, whether I do it for one customer or 100 customers, is the same. So all things being equal, I'll go for the one that has 100 customers.
Yeah, that
And
makes
so
complete sense.
that's the only reason why we're not doing every cool thing under the sun yet. Over time, with more funding,
Yeah.
with more traction,
Well,
obviously that's places that we can expand into. And our differentiator is the flight time. So we can go into those spaces when we're ready.
that's pretty cool. The things that through my brain are, the real estate world is plagued with, just from the time you see a for rent sign to the time they get opened.
Mm,
Today, most brands they suffer through 18 months of this, right? By the time
mm,
someone goes and sees it, goes and looks at it, gets it back to corporate, gets it back to, hey, we approved this. Now we're going to move to a analysis stage, getting the team out there to do the analytical work, right? As we can start to take each of those components and go dramatically faster, right?
mm,
I can imagine deals happening way quicker. With the invent of AI, now you can do demographic modeling at 10,000x. That ability to go find sites and know that you'll be profitable because just the way that you're looking at them will be so much more intelligent. And
mm.
now the analytical part of it kicks in, right? How do we get from it's approved to move forward to the analytics of it and being able to get a deal done? And I think that's where all of what you're doing was so intriguing for me. Like the idea that we could get, do a scan of a property in hours rather than, days.
I think with our specialization, we're very careful to say to customers, anything under about 100 kilometers linear or 100 square kilometers, you're better off using a multi-rotor. It's sort of more versatile. They're commoditized. They're very cheap. You can place them exactly where you want. They can stop. They can hover. They can fly backwards. All of that. So anything to do with property development at a small to medium scale probably is not our sweet spot. But if you're developing, a whole city, then we can talk. So
Yeah.
but absolutely the insight. And again, the interesting thing is our value add is the data collection. So we have the ability to put that camera in the air for long enough to get that data. The analysis side is a whole other ball game in terms of there are different companies that do it that are very specialized. And again, we see that as a partnership. Like we don't necessarily go into the data analysis in depth. Like we'll get it to the point where it's correctly geotagged and it makes sense and it's in the right format. But again, you make that conscious decision to go, how much of that horizontal value chain do I want to capture? And we build the airframe, we integrate it, we do operate it, and that then comes back to that, how do you actually get it to market? We capture the data, we clean it up, we then partner with someone to do the analysis. But that analysis space is moving at light speed.
Light
It's
speed. Yeah.
and it's hungry. Like you need to
Yeah.
feed that data in. And so the fact that we can collect it makes us a very good sort of complement.
I kind of see the world, just like AI does, where it takes a need or something it's trying to solve, it breaks it down into multiple lanes, solves them at those lanes, and it moves them up to the next lane. Right, being able to work on multiple lanes. I kind of feel like that's where we are right
Mm,
now. Like as you're working on your lane right now is longevity, being able to keep it up in the air, distance and flight, and payload ability. somebody else is working on that analytical work for the analysis work, and being able to look at the data that gets contained from there. Somebody else is working on storage and transmission, right? I feel like as those things get smarter and smarter, they'll start to collect and really move up and be, that's the multiplication that happens, right? The multipliers. And you can see that in like every podcast I do. I get to see you working on this portion of it clearly. I can, see, the amount of time you're spending and finding, the longevity of using carbon fibers and every nth detail to the aerodynamics of it, taking your experiences from the World Cup, and really bringing that into that space. And you can just imagine there's somebody on the other side of it doing their solves at that same level of detail.
I think it's an ecosystem, and it all leverages each other. You look
Yeah.
at a lot of the stuff that we have on the drone now in terms of solid state IMUs, so inertial measurement units. Really, you can trace those back to mobile phones. They're the thing that is able to tell whether you're in portrait or landscape, right? The orientation, again, it's not the same, but it's similar technology. It's enabled by that. As I was saying before, the fact that we can now buy CAN servos and we can buy CAN GPS and all of that stuff came out of, a lot of it's out of autonomous cars where LiDAR, GPS, all that stuff had to sort of step up to do that job. And we're very eclectic in where we sort of look in terms of the supply chain. And we also, as I said, partner with data analytics, partner with payload suppliers. So we don't build our payloads. We're not camera people, but cameras are getting better. So I remember the very first camera we put in one of our drones was a Sony point and shoot camera. So it had a viewfinder and a trigger and all stuff that you don't need when you put it on a drone. And we had to hack it. We had to go in through the hot shoe, the flash attachment to get the trigger feedback for when the camera had fired. Now we can buy something called a phase one, which is a camera designed to go on a drone, which is just your charge coupled device with a processor in a little box and a lens. So that kind of thing all helps sort of the rising tide lifts all ships. And the interesting thing with that is going back to America's Cup, by definition, being in that sort of competitive environment, being eclectic and being multidisciplinary is really key, and that cross-pollination. So America's Cup structural guy will look at Formula One, will look at aerospace, will look at mining and go, how are these guys using that material and how can I pinch that and put it on my boat to make it a little bit lighter, a little bit more efficient? We were looking at things like genetic algorithms in the early 2000s to go, how can I iterate more quickly on my design variations? And you're dealing with, you've got a carbon fiber hull, but then you've got lead in your keel, and you've got titanium over here, and you've got high-tech fibers in the sails and in the ropes. Where do I pinch that from? Who do I collaborate with? Where do I learn to bring it all into my purpose?
I think that's one of the joys of having AI is that from a design point of view, the human has their experiences, right? You might be able to go as a experienced designer. You have this toolbox that you go to. I see it in the architecture and design world all the time. An architect may have this in his toolbox or her toolbox. They've got these tricks they use, and you see it in their plans, right? It's almost like a chef, the same thing, right?
Mm.
Like you sit with a chef and they have a characteristic to their food that they've learned, right? The way they cook, the ingredients they use, right? I feel like that's the same. And I feel like where AI comes in, it now brings you access to material data at call it 10,000x or 2 million x, right? I just heard a study that there's been over 2 million new materials created since the invention of AI, right? Products that people haven't even been able to get to yet, alloys
Mm.
and materials that just people are racing to go try on.
Mm. And I think it's at every level because you've got the material
Yeah.
sciences level, like the fundamental chemistry of the material, where again you see it in medicine, you see it in polymers. How do I combine the atoms and the molecules in a way that gives me something with this shape, which will then have those properties? And that then has to work its way through an industrial process, and someone has to make it at scale, and it has to become accessible. But then at the level of the sort of practical material experimentation, where you go and buy a thing, you build a prototype, you put it in a machine, and you figure out what properties it has, and then you feed those back into your finite element analysis model and you refine it. That's also happening in parallel. But there's a level of, I guess, practical testing being balanced and sort of being encroached into by simulation. So again, 20 years ago in America's Cup, you had tank testing. You built a model and you towed it through a tank to get the way it moved through the water. That has gradually been phased out, not because of any rule constraints, but because the computational fluid dynamic is getting so good that it no longer
Wow.
needs that valid. So for a while, the tank testing was your data source.
Yeah.
Then the tank testing became your way to refine and calibrate your computational fluid dynamics, or CFD. Now it's basically the CFD is good enough that you don't need to do any tank testing or wind tunnel stuff. So again, within reason, because as you move further away from a known model, you still need to have a real world check to make sure that your expected extrapolation is actually bearing out and there's not a step change that you're missing. But that ability to simulate more and more and to do practical stuff less and less just allows you to iterate faster.
Genius. It's just genius. It's like it makes me giddy to think about the speeds by which we're learning, and taking the dead weight out of it. Right, like that tank testing had to be time consuming, expensive, a lot of work to go through, and there was a real impact to that. And today, now you get these models that can do it on a computer in seconds, and do it at a level that's so precise that you're close enough.
Yeah, absolutely. And again, you iterate, and it's interesting even for us, like with the drones. Um, if you're building an airliner, you need to get it pretty close the first time because if you
Yeah,
have to change something radical, it's very expensive. It's a big machine, it's complicated. With the drones, like we can build a wing in a day, bend it over our knee and go, okay, this more or less has the properties that we want. Go fly it, see if it breaks in a controlled environment. So again, you're always weighing up the options. You're saying in some contexts, the practical testing is slow and expensive. And so you look at SpaceX, right? You build a rocket, it fails. It's a big thing that's failed, but you've learned a lot. Um, but in some contexts, the practical testing is still the most economical and the fastest way to go. So having that judgment is important.
how do you see this composite material, this material science impacting our future, right? How do you see that impacting the products we're creating in our future?
We've seen it just in the last 20 years. We've gone from something that is very labor intensive. So again, the reason carbon fiber is expensive is yes, the material per square meter is expensive because there's a process there to make it and to weave it and to impregnate it. But the bulk of the cost was the labor, because you had to make a mold and you had to have a human sit down and place the individual patches of material on the mold, put them in a vacuum bag, put them in an oven. And so that was really the driving factor. As it has become industrialized and available at scale, so one of the big sort of step changes was, okay, Boeing started to use it to make their fuselages. Suddenly the volume went through the roof. It was available. There was a shortage for a while, then it became cheap. Um, and you start looking at automated filament winding with a robot, or you start looking at rapid ways to just sort of put it roughly in the mold, and then you just use pressure and heat to get it where you want it. And now you're starting to see initially supercars, now sort of premium cars, eventually it'll be economy cars, using it for the monocoque tub for the structure. You've got a material that's potentially stronger, lighter, more durable, more resilient than steel, but steel has this long history of being very well known and all the processes being
Yeah.
optimized.
Cheap, easy,
And so that,
known.
that
Yeah.
replacement is like we need to get to that scale and process optimization, and things like how do you recycle it? I mean, steel you just melt it again. Carbon fiber is a composite material. You've got to separate out the resin from the plastic, and that again impacts on the economics of it. But we're already seeing recycled carbon fiber come out where it's just chop strand mat that's been put together. So as scale becomes a thing, the methodologies adapt, and then it becomes more. And all it means is that the applications where it's worth using it change because the cost benefit changes. So the reason carbon fiber is considered cool and exotic at the moment, and you see it on Formula One cars, is that Formula One has that premium on performance where spending $1 million to get 0.1 of a second is worth it, and so you use it. On your commuter road car, that's not the case. So to get 0.1 of a second, you don't want to spend $10 million. And so the optimization is different, and every material is like that. Then the other thing that's coming into play now is 3D printing and getting to the point where you can incorporate fibers into a plastic matrix that starts to approximate epoxy and the now traditional pre-preg methods. Means that again, that's going to start to encroach, and you're going to get in a situation where you're using a material that's a little bit not quite as nice, but you can use it very efficiently. And you can iterate. You don't need a mold, so you can change it every time. So all that stuff's moving pretty quickly.
It's fun. Where we're going to go, it's unbelievable. I think it does make me giddy inside thinking we're living at a time today where just our ability to make change this fast making some of us, or making most of us nuts. But at the same time, it makes me, silly inside with what our opportunities are and where this can go. And I think that's the gift to give everybody. It's like, look, we're going to go through a lot of change right now in this down moment. But if you keep your head on a swivel, keep your head up, right? Don't get overwhelmed. Don't get scared out, right? A lot of people are like, oh my God, they get overwhelmed and shut down. Stop. Now's the time more than ever to be listening and watching and seeing opportunities. How do you take the technology you're using here with drones and apply that to whatever part of your business is that will impact the ability for whatever your next idea is much, much quicker. So a lot of fun. I think that I look forward to your continued playground of ideas. Keep bringing them to the surface. In fact, I've got some ideas I'm going to play with you on and see what we can do to do some site work a little bit faster and kind of communicating on that. I think that'd be kind of fun to play there. And if people want to get a hold of you and bring you into their playground for their ideas, what's the best place for them to catch up with you?
For Carbonix, it's the website, so carbonix.com.au, because it's Australian. For me personally, it's probably LinkedIn, Dario Valenza.
I'll put all the contacts for that down below in the description, folks. You'll be able to get to Dario easy. It's a lot of fun. What he's working on, the things he's done. You got to get some of his stories out of him. They're amazing. The World Cup stories are really neat to hear about. So reach out. We'll put all that description down below. Dario, anything else you want to tell the audience today?
Look, I think to tie it up on what you just said, you come across as a techno-optimist, and I think most people who choose to go into any innovative field are naturally techno-optimists. They see the path through to solving the technical problems and making the world better. I think we need to work on making the rest of the world techno-optimistic. And so that's everything from regulations to investment to restrictions that we've had before that have held technology back. And I think being able to evangelize that and to tell people that, yes, it's actually going to be good. Yes, there are risks, but there are people who are very committed to overcoming them. So let's all be techno-optimistic.
Absolutely. It is so funny when we look at ourselves, but look, we've messed some things up. And because of that fears, it's completely natural. We get it. As humans, we've done some dumb things. And I think a lot of us will play that tape over and over again. Instead of looking at the tape going, man, the things I can do today compared to what the amount of abundance we have today in our world compared to where we were even, today. If I told my grandmother that I have to, when I go to Costco, I have to buy 12 head-sized muffins. They don't even sell you one. That she'd kick me in the shins. So, or 36 rolls of toilet paper. She'd be like, "What's wrong with your bottom?" Right? Her whole neighborhood didn't use that much. So I think we're there. We got to continue to go there, Dario. I'm so grateful to have you on the podcast today. I really do appreciate it.
Okay, my pleasure.
Audience members, last week we had an amazing week. We had 20,000 downloads. It was amazing week. But we noticed that there were 65% of you that didn't make it, that made it to the end of the podcast, but you weren't subscribers. And that blows me away. Could you take a second right now and like and subscribe? It means the world to Alyssa and Joe and all the team in the background that hunt hard and long to find us amazing guests like Dario to come on the podcast. Our numbers do make a difference. It does help attract guests to the show. So if you could take a second and do that now, we're so grateful. And as always, thanks for listening.